Good morning, guys. Anjani Kumar here, dealing Power System 2 for third year electrical students. In the last session, we have successfully completed our skin effect concept. Alright, so what is the definition of a skin effect? And after that, how the skin effect will develop around the conductor? Alright, what are the factors that affects the skin effect? And how to reduce the skin effect. So this is very important concept that we discussed till now. Right, I hope each and every student understand the concept of skin effect. These are interview questions. Definitely, if you go for a technical interview, so definitely the person will ask regarding power system only. They won't go for a machine, they won't go for a control systems, they won't go for other topics like power electronics, right? So definitely they will stress on you based on the real concepts, right? Real visible concept, like what is a skin effect, right? What is hydroelectric station, what is a thermal station, how it will work, right? So what is a skin effect, what is a corona, what is a Faraday effect in a controls in a power system, right? What is a insulator, right? Different types of insulator, right? These are the things they will ask, because these are very nearer to the realistic life. So that's why they'll stress on this type of a concepts, like, right? I'll briefly explain the phenomena, that's it. So what is a skin effect? Right, what is a skin effect? It's a phenomena in which the surface of the conductor, which is having a maximum current, and the near the center of the conductor, which is having a minimum current. So this non-uniform current in the conductor, we can call it as a skin effect. Right? Skin effect is nothing but non-uniform distribution of current. Current, we can call it as a skin effect, right? So how the skin effects develop? We already discussed. At the center of the conductor, the flux linkages are very high. If the flux linkages are very high, means the inductance should be very high. If the inductance high, means inductive reactance is high. If inductive reactance is high, means impedance is high. If impedance is high, means the current value will be less near the center of the conductor. Near the surface of the conductor, the flux linkages will be reduces, thereby the inductance will be reduces, thereby the inductive reactance value will be reduces, thereby the impedance reduces, thereby the current will be increases. Right, the center of the conductor, the current will be reduces, surface of the conductor, the current will be increases. This uneven in a single conductor, you are traveling, you are pushing the power, but there are different currents are available at the conductor. So this is definitely a problem. So this effect we can call it as a skin effect. Right. So if you take a conductor, so always the current flow on the outer surface, right? Inner surface we don't have any current, so there is a waste part in a conductor, right? That's we think that definitely that will be a waste part, so the cost for that also waste, right? So we need to avoid this thing, right? So this part we don't have any current, so this part which is having some copper wire na, so some turns wire na, so it is a waste part na, so the cost also based on this thing na. So that is one note that previous polytechnic examinations we got this type of question, right? I hope I already discussed in the last session how the question will be the waste part in a conductor while transfer the power from sending end to receiving end. Surface of the conductor, center of the conductor, right, middle of the conductor, and none of the above. So what is the answer? The waste part in the conductor while traveling the power is nothing but center of the conductor. Why? Because at the center of the conductor we don't have a current. So if you don't have a current in the transmission system, means that's a waste. So we are putting some cost over there. So that is a waste purposes, right? And what are the factors that are affecting the corona means? The factors affecting the skin effect means the first one is a frequency. If a frequency increases, skin effect increases. Right? If a temperature increases, skin effect increases. If the diameter of the conductor increases, skin effect increases. Right? After that, type of the materials used. Right? If a material which is having a high permeability, epsilon, high permeability which is having a skin effect is high. So always looking for low permeability materials to be used to reduce these type of skin effects, right? A design consideration. So always solid conductor usage on core, definitely the skin effect will be increases. So we just go for ACSR conductor. That means two different layers, right? So the conductor which is having a aluminum and steel, aluminum core, steel reinforce oriented. So ACSR conductor. ACSR conductor and UCL. So definitely with this we can reduce these are the factors that are affecting the skin. How to reduce the skin effect means the first thing is smaller diameter. The conductor which is having a smaller diameter, the skin effect will be very reduces. That means the center to surface distance is reduces. So if you are reducing this means current change in also reduces, right? And the second one is small thin wire. Thin type of conductors that we are going to choose. And the third one is if you use a ACSR conductor, definitely the skin effect will be reducible. And the fourth one is halo conductors, right? If you use a halo conductor, you can easily reduce. It can be used in a traction, right? Railway systems that can use these type of conductors to avoid the skin effect concept, right? In HVDC lines, we don't have a skin effect because there is no frequency, there is no inductive reactance, so the impedance will be Z or near the conductor, impedance will be R surface of the conductor. The effective impedance, effective resistance will be a constant from the center to the surface. There is no unequal values of current, so that's why we don't have a skin effect in HVDC lines. Right, this is about the total skin effect concept that till now we discussed. Now we move into the very very important concept. Second factor that affects in a transmission lines while power transferring from the sending end to the receiving end. So that is called proximity effect. Very very important. So it's better to understand how these type of factors affecting. That's it. Nothing will be important, right? So you, as a power system engineers, you must know what are the things happening in a power system. You just have a brief idea, right? What is a power system? What is a transmission? What is a distribution? Right? What is a generation? What is utilization? Right? How the power transfer? What are the factors that are happening? How the power is going to be transferred? How the transmission lines are erected? These are the basic things we need to know, right? Right, so proximity effect. This is also very very important factor that affects the transmission system, right? I'll state the phenomena first, then I'll explain how the proximity effect happening in a transmission system. Right? Listen to me carefully. For suppose if this is a conductor, right? So we have a conductor, aluminum ACSR conductor is there. So this is a cross-sectional area of ACSR conductor. Now I am dividing this conductor in cross-section. That assume, right? Dividing this conductor like this. Just assume, right? So a conductor which is having two parts, right? Now the current is going to be traveling, right? So whatever the voltage that applied, that voltage flows to the conductor conductor from sending end to the receiving end. So I am assuming that the conductor can be divided into two parts. We are bisecting that. That means you will get that the current that can be flowed on one top only. So either here we can flow the current, here we don't have a current, at least, and one top only the current will flow. The other bottom, which we won't have any current in this. So this phenomena we can call it as a proximity effect. See, so what's the proximity effect? States that if you take the conductor, on the top of the conductor the current will flow, on the bottom of the conductor we don't have a current. So if we don't have a current on the bottom of the conductor, so this is a waste part now. So why can't we take these type of parts? So that is a proximity effect. I hope it's clear. This is a cross-sectional area of a conductor. So the conductor will be like this, right? You are assuming that, right? The current is 22 kV line is flowing through the current. So that means if you bisect this thing, right? So only top of the conductor side the current will flow. The bottom, which is having a no current, right? So these type of phenomena we can call it as a proximity effect. Now, states that on one side of the conductor the current will flows, on the other side we don't have a current. So the proximity effect states that on one side of the conductor the current will flow, on other side of the conductor we don't have a current. So this effect we can call it as a proximity effect, right? In a skin effect, so near the center of the conductor the current is a minimum, and the surface to the conductor the current is a maximum. So this unevenness of a current we can call it as a skin effect. But what's the proximity effect? State that only one side, either top or a bottom, only the current will flow, right? Only one side, either top or a bottom. If a top side current will flow, there is no current in the bottom. If a bottom side current will flow, there is no current in the top. So only one point, one side of the conductor the current will flow, other side there is no current will flow. These phenomena we can call it as a proximity effect, right? So proximity effect can be explained in detail with two situations. Right? The first one is, if you take two conductors with current in same direction, you take a two conductor with current in same direction, and the second one is, if two conductors with current in different direction, right? This proximity effect that can explain with the help of, if you take a two conductor, like this is a two conductor when a current in a same direction, right? This is the first situation. If you take a two conductors with the current in opposite direction, right? So in this with this type of situation we can clearly explain the concept of proximity effect. I hope you understand what is a proximity effect. Proximity effect means, if you take a conductor, on one side of the conductor the current will flow, the other side of the conductor we don't have a current. So this type of phenomenon, that is a drawback now. If you current flowing through the conductor means all the conductors conductor material should carry the current. Top of the material carry the current, and the bottom of the current material not carrying the current is a drawback in the system. There will be a losses will be present, right? So this phenomena we can call it as a proximity effect. So how the proximity effect can be explained with the help of two ways. The first one is the two conductors with current in the same direction. If you take a two conductors with current in a different direction, right? I'll explain in detail one by one. First one, two conductors with current in same direction. Right? Now we'll clearly see. We have a two conductors, right? Right? So we have a two conductors, right? I just draw, there will be a cross section area, but for a clear understand, you have a two conductors. Now you are assuming that the current in a same direction, right? You are assuming the current in a same direction, right? So the current in a same direction, right? You know that when current flows through the conductor, there will be a magnetic field around the conductor, right? So there will be a magnetic field around the conductor, right? So this is a magnetic field that you will think it of. Right? So this will be a magnetic field. So here also the current will be flows, means it will be a magnetic field. You know the Ampere's law. Conductor kunda current పోతుందంటే దాని చుట్టూ ఒక magnetic field create అవుతుంది. That's now you will say with the help of Fleming's law, you will say the direction of a magnetic field. If the current is flowing inner side, that current is flowing like this, so the flux direction will be like this. I hope it's clear, right? If the current is for this part, the current is in direction, the flux will be in this direction, right? The current ila veltundi, the flux ila velali. So the flux direction will be like this, okay, downwards. So that is a clockwise direction, right? I hope it's clear. For this thing, the current is like this, the flux direction will be like this. Right? Now with this, the current will be in this direction, the flux will be like this. You will see the flux will be like this. Right? You will see. Right? These are two different two conductors which is carrying the same current. Whenever current flowing through the conductor, there will be a flux will be developed. The flux direction will be given by the Fleming's law. Right? You will see the direction of these two. This is one type of a direction, and this is a other type of direction. So there will be a opposite flux. So whatever this opposite flux is going to be attracted now. So this flux is attracted means, so this is a one type, this is another type. So it is a positive, it is a negative. So these are attractive. That means the total flux will be, what about the total flux? So there will be a zero flux. Right? This is a positive flux, this is a negative flux. These two fluxes are going to be cancelled out. So this will be zero flux. right? Zero flux. How the flux's direction will be? You will see the flux direction. So we don't have any flux over there. How the flux will be travel like this? Because at the center we don't have any flux, because the positive flux and the negative fluxes are going to be cancelled out, so both are attractive means these two fluxes are going to be cancelled out. So here you will get the flux linkages are a maximum, right? Here the flux linkages are a maximum, here the flux linkages are minimum. Minimum means very less, small. We'll see. Here the flux linkages are maximum means what is inductance? Psi by I. If psi is increases, inductance will be increases. If inductance will be increases means what about XL? 2 pi FL. XL also increases. Right? If XL increases, what about a ZL? ZL is equal to JXL. XL increases, your ZL also increases. Your ZL increases, what about the current? The current is equal to V by ZL. So if it is more high, if it is very less, there is a small current will flow. That much we don't have any current over here. Right? Here also similar situation. I value will be very less. Here the situation you will see. If a flux is minimum, the flux is minimum. So that means what about the inductance? Inductance is minimum. XL is minimum. So ZL is minimum. So what about the current? B by ZL. ZL is minimum. The current will be increases. Here you will get the current value. Current is a maximum current. Right? On the one side of the conductor we don't have any current. On the other side of the conductor you are having the current. Now we'll see how the situation will be. For suppose this is a two conductors, right? So you are getting the current this side, right? You will see the current in this side. For a conductor, current in a bottom side. For this conductor, your current in a this side, right? On this side we don't have any current, and this side we don't have any current. So the direction will be like this. Alright, so you will say this is the cross sectional area of a conductor. You will think it up. Right? This side you don't have any current. So this side only you have a current. So this side you don't have any current. Only this side you are having a current. So that means, so this difference in current, on the top of the side, one side of conductor you are having the current, on the bottom side we don't have any current. So this phenomena we can call it as a proximity effect. Right? I hope it's clear. Nothing is there, simple magic, right? So if you take the conductors which is having the same direction, there will be a flux around the conductor. The flux direction will be given by the Fleming's law. If you take the flux direction on the center side, both the flux are going to be in a different, right? One is a positive direction, one is a negative direction. So reverse direction, right? All the flux is going to be cancelled out here, and the minimum flux will be produced here. Here we will get the maximum flux. So the flux maximum, the current will be minimum here. Here also the flux maximum, the current will be minimum here. But here the flux is a minimum value, so that means the current is a maximum value. So at this part we will have the current, and this part we have a less current. So this phenomena we can call it as a proximity effect, right? I hope it's clear, right? Now we'll enter into the concept of two conductors with current in different direction. Right? You will take the two conductors. Here assuming the current in one conductor current like this, another conductor current like this, right? So there will be a magnetic field around the conductor. How the magnetic field will be? Right, for this conductor the magnetic field will be like this. I mean, these two are interlinked. If it is interlinked, it's very difficult for your current direction. So that's why I'm separating it. But these magnetic field and these magnetic fields are both are touches, right? Now the current direction. According to the Fleming's law, there will be a current direction. If the current is like this, the flux direction will be downwards, the clockwise direction. Right? For current direction is like this, so downwards, right? Downwards. See, downwards. Downwards means the flux direction will be like this, right? Downwards. It will be like this. How the flux direction? We'll see. Right? Now we'll see. Now we'll see. These flux and these fluxes both are in a same direction. So what happened? If these flux and these flux both are in the same direction, the net flux will be increases. So this is a positive flux and this is also positive flux. So these flux are going to be added, right? Aiding. These flux are aiding means the total flux value will be very high. Here the total flux value will be, the flux linkages will be very high. Right? Here the flux linkages will be minimum when compared to this one. So here the flux linkages is minimum when compared to this thing. Now we'll see the current direction. The flux is minimum means, so inductance is minimum. If inductance means minimum means XL is minimum. So XL is minimum means ZL is minimum. So what about the current? The current is a maximum. Right? Here also same. ZL. Here also same. So L is minimum, XL is minimum, ZL is minimum. And what about the current? Current is a maximum. And now in this side how it will be look like, right? Psi is very high. So what about the inductance is high, XL is high, ZL is high. So what about the current? Current is a minimum. Right? So on this side, because on this side between the two conductors the current is a minimum. On the other side of this two the current is a maximum. So this phenomena we can call it as a screen effect. We'll see how it will be clearly. This is our two conductors, right? Here at what side the current will be flat? So this side the current will flow and for this side current will flow. Right? So if you take this is a conductor. Right? Right? That means this side the current will flow. This side there is no current. This side there is no current. This side the current will flow. So only on the top of the conductor, either top or a bottom, whatever it may be. If you take two conductors the same direction, the current will flow on the bottom side. If you take a two conductor in different direction, the conductor, definitely the current will flow on the top of the conductors, right? This side the current will flow, this side there is no current will flow. This side the current will flow, this side there is no current will flow. This phenomena, so we can call it as a proximity effect, right? So this is about a proximity effect, how the proximity effect can be explained with the help of two situations. It can be explained with the help of two situations. The first one is the conductors with different direction, the conductors with the same direction. So you can explain, right? I hope it's clear. Nothing is a simple concept. Try to understand, right? Now we'll discuss about similarly. So what are the factors that are affecting the proximity effect? Simple concept, right? Nothing is there. The same factors that affect the skin effect, because these are interlinked. Skin effect, these are current related, right? Current related, right? So if a current increases or decreases, means your resistance is going to be increases and decreases. The losses are going to be increases, the efficiency reduces, and voltage regulation also reduces, right? If on the top of the conductor the current is increases, that means the resistance is going to be reduces. At the bottom of the conductor current is reduces, resistance is increases. Here the losses is increases. That means efficiency is reduces, voltage regulation is reduces. That's it, right? On one side you are getting a losses, on other side you are not getting a losses. It's a disadvantages, right? What are the factors? The first factor is the frequency. Same factors what you discussed in a skin effect, those are continuous, right? So frequency increases, the proximity effect also increases. I don't want to explain. Nothing is there. If a temperature increases, your proximity effect also increases, right? Solid conductor use chese, solid conductor, the proximity effects also increases. If you take a high permeability materials, right? If the permeability of materials increases, your proximity effect also increases, right? So you are going for ACSR conductor, so in order to reduce the proximity effect, right? These are the factors. If the frequency increases, your proximity effect also increases, your diameter increases, your proximity effect also increases. Frequency increases, proximity effect also increases. Temperature increases, proximity effect also increases. If you use a solid conductor, like circular conductor, right, the proximity effect also increases. If permeability increases, the proximity effect also increases. If you use ACSR conductor, the proximity effect will be reduces. The diameter increases, the proximity effect also increases, right? So how to reduce the proximity effect? Right? The first one, the distance. So distance between the two transmission lines is very high. The first one is a large distance. If you place the two conductors which made up of a large distance, definitely you can reduce your proximity effect. So you are making a large distance means the conductor. That means the flux difference will be very less. Right? Contamination of a flux between one conductor to another conductor is very less. So that's why the same flux will be rotated in a single conductor itself. Right? And the second one is, so if you want to change the how to reduce the proximity effect, you can reduce the frequency or increase the voltage. So with this we can usually reduce the proximity effect concept, right? You can usually reduce the proximity effect, but it's very difficult to reduce the frequency. Why? Because in AC systems frequency is a constant, right? frequency reduce cheyala, voltage increase cheyala. But in the case of AC system, the frequency is constant, so it is not that much useful. So we can increases or decreases the voltage with the help of regulators, right? So you can use this one to reduce this one. So right, so these are the factors to reduce the proximity effect. Right, first you can make a larger distance to reduce this type of proximity effect, and you can reduce the frequency and increases the voltage. So this is a concept that we need to reduce. So frequency reduces means it's very difficult. Right, if you increases the voltage means definitely with the help of regulators you can increases or decreases the voltage levels. Right, this is about the proximity effect. I hope it's clear from your side, from my side. Right, if you have any doubts, please do watch one more time the video. Definitely you will get a clear picture about what is the skin effect, what are the factors, what are the advantages, what are the disadvantages, right? How to reduce the skin effect, right? What is a proximity effect? What is the condition of a proximity effect? What is the situations that are made in a proximity effect? What are the factors affects the proximity effect, right? How to reduce the proximity effect? These are the things. These are very very important technical concept for your end exams, and also for GATE, IES, and for interview purposes also. I hope it's clear. Thank you for now. In the next session, we start Ferranti effect. After that, we'll start Corona. With it, we will conclude this unit. Thank you very much.